Early 1945, the waters near Japan's coast were calm, cold, and hiding a secret that would shake Japan's engineers to the core. An American F4U Corsair fighter had gone down after its engine failed during combat. The pilot managed to eject before the aircraft hit the freezing waves of the Pacific. Within hours, Japanese patrol boats arrived and surrounded the wreckage floating in the gray water. What they pulled from the sea wasn't just another enemy aircraft. It was a machine that would expose the enormous gap between Japan's wartime technology and the industrial power of the United States. For years, Japanese pilots had faced this strange gull-winged fighter in the skies over the Solomon Islands, the Philippines, and now even above their own homeland. They had fought it, feared it, and respected it, but never truly understood it until now. When the Japanese engineers finally got their hands on this almost intact Corsair, they were astonished. What they discovered went far beyond weapons or speed, and it was a glimpse into the future of engineering itself. This is the story of the moment Japan realized just how far behind they had fallen, the day they captured an F4U Corsair and admitted they had never seen anything like it. The Corsair didn't appear out of nowhere. Its story began long before it ever crossed paths with Japanese engineers. Back in 1938, when the U.S. Navy demanded something truly extraordinary. The Navy wanted a fighter that could fly faster than 400 miles per hour, carry heavy weapons, travel long distances, and still be able to land safely on aircraft carriers. At that time, this goal sounded impossible. Most fighters barely reached 350 miles per hour, and carrier planes were usually slower and weaker because of the stress of carrier landings. But the designers at Chancevod Aircraft, led by Rex Beisel, decided to take that challenge head-on. Their idea was bold, maybe even crazy at first. They wanted to build the plane around the most powerful engine ever made for a fighter. That engine was the Pratt & Whitney R2800 Double Wasp, a monster with 18 cylinders and more than 2,000 horsepower. It was nearly twice as powerful as what most aircraft had in that era. But with great power came a serious problem: the propeller. The propeller that could handle this engine's strength was enormous, more than 13 feet in diameter. If they used normal landing gear, the blades would hit the ground. The team had to find a genius solution. That's how the Corsair's iconic inverted gull-wing design was born. Instead of straight wings, the designers bent them downward from the fuselage before leveling them out. This strange M-shaped design gave the propeller enough clearance and also reduced aerodynamic drag. When the prototype, known as XF4U-1, took off for the first time on May 29, 1940, test pilot Lyman Bullard Jr. could already feel its raw power. Just a few months later, the aircraft became the first single-engine American fighter to break 400 miles per hour, a headline-making achievement for its time. By 1942, production models were ready for combat, and the U.S. Marine Corps received the first operational Corsairs. These planes were destined to fight in some of the toughest battles of the Pacific War. But at first, things didn't go well. In February 1943, during the so-called St. Valentine's Day massacre over Bougainville, several Corsairs were shot down. The results were disastrous. American losses were far higher than the Japanese defenders. It was a harsh lesson. Technology alone couldn't win battles. However, American pilots quickly adapted. They realized the Corsair wasn't built for tight, slow dogfights like the Japanese Zero. Instead, it excelled in boom and zoom tactics, diving fast, striking hard, and climbing away before the enemy could react. Once pilots mastered this style, the Corsair became a nightmare for Japanese airmen. It was faster, stronger, and could take heavy damage and still keep flying. By 1944, it had gained a fierce reputation across the Pacific, a symbol of American engineering dominance. And it was this very aircraft that 2 years later would fall into Japanese hands and reveal the truth behind its power. It happened in early 1945, the final, desperate months of World War II. Japan was being pushed back on all fronts. Cities were burning from air raids and fuel was running out. Yet in the cold waters off Japan's coast, something remarkable happened. An American F4U Corsair suffered engine failure during a mission and crash-landed into the Pacific. The pilot managed to eject and was later rescued, but the aircraft, mostly intact, floated helplessly on the waves. Within hours, Japanese patrol boats spotted the wreckage and rushed to recover it. They didn't yet realize what they had found. When the aircraft was pulled aboard, dripping with seawater and fuel, engineers immediately recognized the outline. That distinct gull wing could only mean one thing. They had captured a Corsair. To the Japanese military, this was more than just a trophy. It was an intelligence goldmine. For almost 3 years, their pilots had faced this mysterious aircraft in the skies, but never had they gotten their hands on one in such good condition. The captured Corsair was quickly transported under heavy guard to the Yokosuka Naval Technical Arsenal, Japan's most advanced aviation research center. There, the country's best engineers and scientists gathered to examine every inch of the machine. When the Corsair finally arrived, soaked with salt water but mostly intact, the researchers were stunned. They had seen American planes before, broken, burned, or half destroyed, but never something this complete. Inside the hangar, technicians and officers circled the aircraft in silence. Some took notes. Others just stared. Its size, its proportions, its rugged frame, everything about it felt powerful and unfamiliar. The engineers began their study carefully. They started by photographing and measuring every surface. A wingspan of nearly 41 feet, a length of 33 feet, and a folding wing system so advanced it looked like something out of science fiction. They examined the inverted gull wing shape that had puzzled pilots for years. It wasn't just for looks. It was a perfect blend of function and design. It allowed shorter landing gear, better aerodynamics, and greater propeller clearance. But what shocked the Japanese team most wasn't what they saw. It was what they felt. The build quality, the metalwork, the smooth rivets, and precise joints. Everything screamed industrial power. They realized that this aircraft wasn't just a product of engineering skill. It was the result of a massive, well-organized industry capable of building perfection at scale. And as they began to open up the panels and examine the inner structure, they would soon discover that the real surprises were hidden deep inside the Corsair's metal skin. Once the Corsair was safely inside the Yokosuka hangar, the engineers began their most important task, taking it apart piece by piece. The aircraft had spent hours in seawater, but its structure was still solid. The aluminum skin hadn't corroded badly, the frame was straight, and even the cockpit instruments remained mostly intact. It was as if the machine refused to die. For the engineers, this was both fascinating and humbling. They started by removing the outer panels, carefully examining the wings and fuselage. That's when they noticed something unexpected. Some parts of the wings were covered in fabric, not metal. At first, this seemed ridiculous. By 1945, most modern fighters used all-metal construction. Why would the Americans cover parts of such a powerful machine with fabric? But soon they understood. The fabric wasn't a weakness, it was a smart engineering choice. The designers had used it only in areas where the structure carried little stress, such as behind the main wing spar and on control surfaces like the rudder and elevators. This simple adjustment reduced the plane's weight and saved valuable aluminum, yet it didn't affect its strength or performance. To the Japanese engineers, this showed a level of resource efficiency and design intelligence they deeply admired. Next, they examined the main wing spar, the backbone of the aircraft. What they saw left them speechless. The Corsair's spar was a massive, single-piece aluminum forging, unbelievably strong and perfectly machined. Japan's factories, strained by bombings and material shortages, could no longer produce forgings of that size or precision. Instead, they had to build wings from smaller pieces joined together, which made them weaker and heavier. The more they studied, the more the differences became clear. Every rivet, every joint, every panel line showed precision. The consistency between parts was astonishing. No misaligned holes, no uneven surfaces. This was the result of strict quality control, something that Japan's war-torn industry could no longer guarantee. Then came the weapons. The Corsair's .650 caliber Browning machine guns were mounted neatly in the wings, perfectly balanced and easy to service. The Japanese engineers admired how cleanly everything fit together. Ammunition feeds, ejection chutes, and charging mechanisms all worked in flawless harmony. The Americans hadn't just built weapons. They had built a complete system designed for efficiency, reliability, and speed in battle. When they tested the gun mounts and internal mechanisms, They were amazed by how smoothly they moved, even after being submerged in salt water. That kind of precision meant one thing: unmatched manufacturing standards. And then they reached the cockpit. The layout was simple, logical, and built for combat. The controls were strong but smooth, the instruments clear and detailed. There were switches and gauges for almost everything, from engine management to fuel systems and electrical power. One of the Japanese officers reportedly said, "Quietly, this is not just an airplane, this is a factory in the sky." When they examined the armor protection, they found 150 pounds of steel plating around the cockpit and a 1.5-inch bulletproof glass panel behind the windscreen. Japanese fighters like the Zero were famous for being fast and agile. But they had almost no armor. A single bullet could set them on fire. The Corsair, on the other hand, was built to take punishment and keep flying. It was clear now. American pilots could survive hits that would have been fatal in Japanese planes. But the biggest shock was still waiting under the cowling: the Corsair's heart, the Pratt & Whitney R2800. Double Wasp engine. When the Japanese mechanics opened it, they found a machine of breathtaking precision. Every component, pistons, rods, crankshaft, looked polished to perfection. The two-stage supercharger system inside was far beyond anything Japan had successfully built. Their own engines often failed to reach full power or required constant maintenance. The American engine, however, could run for hundreds of hours without issue. It wasn't just powerful, it was reliable. The Japanese engineers could only admire what they saw. They measured, photographed, and documented everything. But with each discovery, one painful truth grew clearer. This wasn't just about design. It was about industrial capability. America's factories could produce thousands of these engines, each one identical and dependable. Japan, on the other hand, was struggling to build even a few dozen high-quality units. The Corsair wasn't just a machine. It was a mirror, one that reflected how far Japan had fallen behind in the race of technology and manufacturing. Days turned into weeks as the team at Yokosuka Naval Technical Arsenal continued their study. Every bolt, wire, and instrument was recorded and carefully described. The more they analyzed, the more the mood changed inside the workshop. What began as excitement slowly turned into quiet respect and a sense of defeat. This was no ordinary enemy aircraft. It was proof of a nation's industrial and technological superiority. The Japanese engineers had always been skilled. They had built their own impressive machines, and the famous Zero fighter, the Ki-84 Hayate, the Raiden Interceptor. But compared to the Corsair, those aircraft now felt fragile and outdated. The Corsair's manufacturing quality alone revealed everything. Its aluminum alloys were pure and consistent. Its steel was perfectly hardened. Even the smallest screws and brackets looked like they had been made by master craftsmen. Yet they were actually mass-produced in giant American factories. That was the real shock. It wasn't just that the Americans could design a great aircraft. It was that they could build thousands of them, all to the same standard. Japan's engineers knew they couldn't match that anymore. Their factories were struggling, their materials were running out, and constant air raids made production nearly impossible. Skilled workers were drafted into combat, leaving untrained labor to fill the gaps. Meanwhile, American industry was operating at full strength, producing more planes in a month than Japan could in a year. When the engineers opened the Corsair's fuel system, they found self-sealing tanks made of multiple layers of rubber that expanded when punctured, preventing leaks or explosions. Japanese aircraft didn't have that. A single bullet could ignite the fuel and turn a fighter into a fireball. The electrical system was another revelation: tidy, organized, and reliable. Wires were color-coded, connections were clean, and every circuit had been tested for safety. It was engineering discipline at its highest level. Even the propeller system, a 13-foot Hamilton Standard hydromatic propeller, was stunningly advanced. Its variable pitch mechanism, controlled by hydraulic pressure, allowed pilots to adjust blade angles in flight for maximum efficiency. Japan had tried to copy similar systems but never achieved this level of precision. As the Japanese engineers looked deeper, one realization became impossible to ignore. This wasn't about individual genius. It was about industrial culture. America's power didn't come from a single engineer or a secret weapon. It came from the entire system. Science, production, logistics, training, all working together perfectly. One senior engineer reportedly said, "We are fighting not just their pilots, but their factories, their machines, and their engineers." By mid-1945, as Japan's cities burned and the empire crumbled, the examination of the Corsair became symbolic, a final lesson at the edge of defeat. The engineers continued to take notes even though they knew the war was nearly lost. Their reports were written with professional detail, but the tone carried something new: acknowledgement. In every category, materials, manufacturing, durability, and reliability, America had moved far ahead. The gap wasn't small. It was enormous. When the reports were completed, they were carefully stored and classified, but many of the men who wrote them already knew they would never use that knowledge for war again. Still, they had learned something important, something that would shape Japan's future long after the war ended. Because in the lessons written inside those reports, Japan found the foundation of what would later become its post-war industrial revolution. When the war finally ended in August 1945, Japan lay in ruins. Its cities were burned, its navy destroyed, and its air force grounded. But deep inside the archives of Yokosuka and Tachikawa, a few precious documents survived. Technical reports written by Japanese engineers who had studied the captured Corsair. When American occupation forces arrived a few weeks later, they found these reports in the remains of the salvaged aircraft. Scattered across hangars were drawings, measurements, and detailed analyses of the American fighter systems. The Corsair itself was damaged beyond repair, but the lessons it had taught were priceless. For the Americans, it was just another captured aircraft. For the Japanese engineers, it had been something far more profound, a mirror reflecting the truth about the modern world. They had learned that true power didn't just come from bravery, or tactics, or even individual skill. It came from organization, precision, and the relentless pursuit of quality. The Corsair had shown them what a nation could achieve when engineering, manufacturing, and science all moved together with one purpose. As the years passed and Japan began to rebuild, many of those same engineers returned to civilian life. They took the lessons they had learned during that examination, the respect for quality control, the value of consistency, the beauty of precision, and carried them into Japan's new industries. Factories that once produced weapons now built cars, cameras, and electronics. They applied the same principles they had seen inside the Corsair: efficiency in design, discipline in manufacturing, and an obsession with getting every small detail right. That spirit would soon transform Japan into one of the most technologically advanced nations in the world. The Corsair itself went on to serve long after the war ended. It fought again in the Korean War, providing close air support even as jet fighters began to dominate the skies. Later, other nations, like France, Honduras, and El Salvador, had continued to fly it for decades. In fact, the Corsair's final combat mission took place in 1969, almost 30 years after its first flight, a record that few aircraft in history can match, but its most unexpected. Legacy wasn't in combat, and it was in the minds of those who studied it in defeat. For the Japanese engineers who once stood around that silent, captured fighter in 1945, the Corsair represented more than an enemy machine. It was a lesson in humility and progress, proof of what human ingenuity could achieve when combined with the strength of an industrial giant. Their reports ended with quiet respect. They didn't try to hide what they found, and they didn't make excuses. They simply recorded the facts, and in doing so, they acknowledged something far greater than a lost battle. They had witnessed the power of engineering excellence, and it changed the way they thought forever. The Corsair that once fell into Japanese hands may be gone, likely scrapped or lost to history, but its legacy remains alive in every product, every innovation, and every piece of technology that Japan has built since. Because in 1945, inside a quiet hangar by the sea, a handful of Japanese engineers looked at an American fighter plane and realized that technology, not pride, defines the future. And that realization, born from defeat, became the foundation of Japan's modern rebirth.